So what is current? In this video, we're going to look at what current is in electricity, how it can be measured, and how we can calculate it. Current is the rate of flow of charge through a cross-section of an electrical conductor. Electric charge can also be thought of as movement of electrons. To measure current, we use an ammeter, and the unit of current is amperes or amps, A. Ammeters must be connected in series in a circuit. The current should flow into the positive terminal of an ammeter and leave through the negative terminal. So why does charge flow, and therefore current? For electrons to flow, we need two things. 1. A source of potential difference, which is also known as voltage. This provides the pressure that makes the current flow. And 2. A complete circuit. The circuit must have no breaks in it to be complete. If there are breaks, then no current can flow. In fact, that's how a switch works. To switch an appliance off, we create a break in the circuit to prevent the current from flowing. To switch an appliance on, we close the switch, which completes the circuit and so allows the current to flow. In a series circuit, so all components are in a line one after the other, all the electrons travel through every component and wire as they travel through the circuit. All the electrons experience the same resistance, and so they all move at the same rate. This means that in the series circuit, the readings on all three ammeters will be the same. A1 equals A2, which equals A3. This is not true, however, for parallel circuits. In parallel circuits, the current is shared between the different branches of the circuit. So A1 equals A4, but A1 equals A2 plus A3, which equals A4. To calculate the current in a circuit, we can use this formula. Current is equal to charge divided by time. It makes sense that current is charge divided by time because current is the rate of flow of charge, or I actually find it easier to remember QUIT. QIT. Charge equals current times time. So using the relationship between charge, current and time, can you answer these questions? Pause the video and work it out. Did you get 4 amps and 60 coulombs? Now, to finish with some more questions to test your understanding of all things current. Did you get them right? Charge, ammeter, amps or ampere or A, in series, A1 and A3 are both 0.5 amps, and A3 is 1.2 amps, and A4 is 2 amps. Have you ever heard the expression, resisting temptation? Resisting means to withstand something, and that's what electrical resistors and resistance in an electrical circuit does. In this video, we're going to learn about electrical resistance and resistors. An electric current is the flow of electric charge, composed of negative electrons, through a conductor. It is measured in coulombs per second, also known as amps or amperes. The conductor is made of atoms, joined in a metallic lattice of free electrons. As the current flows through the conductor, the electrons collide with the atoms. Energy is thus transferred, for example, to heat. This explains why a wire with electricity flowing through it often feels warm to the touch. A difference in electrical potential, measured in volts, is needed to propel the electrons through the metallic structure. The voltage measures the amount of energy per coulomb or joules per coulomb. Different conductors will have different metallic structures and so exhibit different resistances in a circuit. A component with a high resistance will need a higher potential difference, or voltage, to move electrons through it compared to one of a lower resistance. George Ohm found a relationship between voltage, current, and resistance in a circuit, which we know as Ohm's law. V equals I times R. R is the resistance measured in ohms, V is voltage measured in volts, and I is current measured in amps. Thus, for a particular wire, if you want to double the current flowing, you need to double the voltage applied. Ohm's law can be displayed in a formula triangle like this. Voltage equals current multiplied by resistance. Current equals voltage divided by resistance. And resistance equals voltage divided by current. Let's try an example. A wire is carrying a current of 5 amps, with a potential difference of 80 volts across it. What's the resistance of the wire? Pause the video for a moment and have a go. We should use the equation R equals V over I, which equals 80 volts over 5 amps, which equals 16 ohms. Remember, resistance is measured in ohms, and the symbol for this is omega. Let's try 2 more examples. Calculate the resistance of the lamp in this circuit. Pause the video while you work out the answers. Calculate the voltage or potential difference across the lamp. Did you get them right? You also need to know that the resistance of a conductor increases as its temperature increases. This is because temperature is a measure of the vibration of the atoms within the conductor. As the atoms vibrate more, so the electrons collide more often, making it more difficult for the electrons to flow and so increasing the resistance. Thus, the resistance of an old-fashioned filament bulb increases as the filament gets hotter and hotter. So that's how resistance happens in a circuit and how it can be calculated. Hello everyone. Today we will be looking at how current relates to both resistance and potential difference, and how we record the potential difference in currents across different components to then calculate resistances. A potential difference is also known as a voltage. A potential difference or voltage is needed across an electrical component to make a current flow. Cells or batteries often provide this potential difference. Ohm's law tells us how potential difference, current, and resistance are related. Potential difference, or voltage, is measured in volts V and is shown by the symbol V. Current is measured in amperes and is described in equations by a capital I. This originally comes from the French phrase intensité de courant, meaning current intensity. Resistance is measured in ohms, which are shown using this symbol, and sensibly is represented by a capital R. These 3 things are linked together in an equation which states that the voltage is equal to the resistance multiplied by the current, or simply V equals I times R. This equation can be rearranged in a manner of ways and is best represented by the triangle. Pause the video and give it a go. Did you get 0.3 amps? We're trying to find the current, so we need to rearrange the V equals IR equation to see that current is the potential difference divided by the resistance. See, it's very easy substituting values into the V equals IR equation. So now, let's have a look at how to measure the potential difference across different components. Earlier, we said that a potential difference is needed to make a current flow, and that batteries or cells often provide this potential difference. Let's have a look at how we can measure the potential difference across the lamp in this circuit. We measure potential differences using a voltmeter. This voltmeter must be connected in parallel with the component we're measuring across. So here it's in parallel with the lamp. Then simply read what the voltmeter says, 1.5 volts. So the voltmeter goes in parallel and measures the potential difference. If we wanted to measure the current, see how we instead used an ammeter, and the ammeter is connected in series, so in a line with the component. What if we wanted to measure both the current and the potential difference? Simply set up a circuit with an ammeter in series and a voltmeter in parallel. Once we've measured the current and the potential difference, we can then use these values and substitute them into our V equals IR equation to find the resistance. So what's the resistance across this lamp? Pause the video and work it out. Did you get 1.5 ohms? Here are 2 more questions for you to give a go. Pause the video, work them out, and click play when you're ready to check your answers. Did you get them right? 5.4 volts and 20 ohms? In summary, we have learned that the voltage is equal to the current multiplied by the resistance, and how to measure the potential difference and the current across components. Thanks for watching.